controlled by this VGS. So when we keep on increasing the negative voltage on the gate, that is the VGS voltage, this negative voltage makes the gate, the channel junctions reverse biased, and when the junctions become reverse biased, the depletion regions around these junctions will be widened and width of the channel is going to be decreased. Therefore, when we increase the reverse bias voltage, the rate of flow of electrons will be decreasing. The rate of flow of electrons will be decreasing because of reduced channel width. Therefore, the slope of the characteristic curve is going to be reduced. So at one particular negative voltage of VGS, channel is completely filled by this depletion region. So channel is completely filled by depletion region. So this depletion region, it is isolating the source and drain. So there is no path for the charge carriers to move from source to drain. So channel length has been completely filled by the depletion region. Therefore, this situation, it is called as pinch off. We say the channel is said to be pinched off. So when channel is pinched off, even you increase the VDS, the drain current ID is going to be 0. So the pinch off voltage, now we can define the pinch off voltage as, pinch off voltage is the gate voltage for which the channel is completely filled by the depletion regions and current becomes 0. So this is the effect of VGS on ID. Now we have seen separately the effect of VDS on ID. Keeping VGS 0, we observed only the effect of VDS. So when see here, VGS is 0 means the depletion regions around the junction remains the same. Width of the depletion regions around the junctions remains the same. Now, VGS equal to 0 means no reverse bias. No reverse bias is provided externally. So if VDS is very small, see this figure, if VDS is very small, when you slowly increase the VDS from 0, current increases linearly with VDS. Because the depletion regions are not altered, the width of the depletion regions remains the same. And the resistance of the channel almost remains constant. Therefore, the current ID, it linearly increases with VDS. Now what will happen? Double plus is there. So if VDS is increased further, what will happen? When the charge carriers are moving from source to drain, a potential drop will be developed along the length of the channel, and this makes the two junctions reverse biased. I repeat, when VDS is increased further, same value I am taking, suppose 4 volts, then here with respect to source, it could be 1 volt. With respect to source, at this region, 2 volts. With respect to source, the region towards the drain, 3 volts, 4 volts. So now, if you observe the PN junction, P is at 0 volts, that is gate voltage. P is connected to gate terminal. So gate terminal, the voltage is 0. So it is 0. And on the N side, a positive potential is there. So on both sides of the PN junction, on both sides of PN junction, if positive potential is there, if P side is at less positive potential compared with the N side, we say that this junction is said to be in reverse bias. So the same situation is applicable here also. So because of this voltage drop along the length of the channel, the PN junction, the junctions are entering into reverse bias state. And this reverse bias effect, this reverse bias, this reverse bias effect is more at the points nearer to the drain end. This reverse bias effect is more at the points nearer to the drain end. One second, I'm zooming it. Because here on N side, at some points in the channel 1 volt is there. The potential on N side is varying. Potential on P side it is fixed at 0, but potential on the N side of the junction it is changing, and this potential is more at the drain end. Therefore reverse bias is more at the reverse bias effect is more at the drain end. Therefore depletion region penetration is not going to be uniform, whereas the penetration is going to be more towards the drain end. If you observe here, the penetration is more towards drain end. So these depletion regions, we called it as wedge-shaped depletion regions. So when you further increase VDS, see here, once the wedge-shaped depletion regions are formed, rate of flow of the channel length, the channel width is getting reduced. When depletion regions are becoming widened, width of the channel is decreasing. So channel width is decreasing, and the channel resistance also decreases. So the rate of flow of the charge carriers decreases. Therefore, the slope will be decreasing. Compared with the previous, the slope will be decreasing. Now, if you further increase this VDS, at one particular voltage called VDS SAT, these two wedge-shaped depletion regions will merge at the drain end, and at this VDS SAT, we call it as the saturated drain source voltage. The rate of flow of the charge carriers becomes 0. So tagutu, it becomes 0. So rate of flow of charge carriers becomes 0 means the number of charge carriers which are moving from source to drain will become constant. So fixed number of charge carriers will be moving from source to drain. So therefore, after VDS SAT onwards, the current is going to become constant. So this current, we can name this current as IDSS. So this current is called as IDSS. So what is IDSS? Drain source saturation current. Drain source saturation current. Drain source saturation current. So why current is becoming constant means, so the electric field, whenever the depletion region is formed, electric field will be developed across the depletion region. See here. So this electric field, the direction of electric field will be always opposite. The electron movement and the electric field direction both will be opposite. So this field is going to become constant because whenever the depletion region length is very, very small compared with the length of the channel, if this is satisfied, then the electric field across the depletion region becomes constant, and therefore once the electric field is constant, fixed number of charge carriers which are moving from source to drain also will be fixed. So that is why current becomes constant. So this is the working of the JFET. Now we will draw the VI characteristics. I'll draw the VI characteristics. There are two characteristics, drain and transfer characteristics. So this side we will draw the drain characteristics. And here we will draw the transfer characteristics. Transfer characteristics. So y-axis is ID. ID, it will be milliamperes. So drain current versus drain source voltage. The curves drawn between drain current and drain source voltage are called drain characteristics. And if you remember the transfer, whenever we use the term transfer, the transfer will be used for the characteristics which is plotted between the input quantity and output quantity. So here y-axis is output current. Now what will be the x-axis? Can anyone? If one is output quantity and the other is input quantity, then the curve is going to be called as transfer. So y-axis is drain current. Now what will be the x-axis for the transfer curve? What will be the x-axis for transfer curve? Are you there in the class? So drain current and drain voltage, drain current and drain voltage, drain characteristics. Drain current is the output current. This is the output current and it must be input voltage. What is the input voltage? Yes? I think you people are not there in the class. No one. అందరికి absent వేసేయాలి. Yes? Whether it is a drain characteristic curve or transfer characteristic curve, VI. So drain characteristics అన్నాం కాబట్టి drain current, drain source voltage. Transfer అన్నాం కాబట్టి current is only one current, drain current. Drain current is output current. What is the input current? మీరు ఆన్సర్ చెప్పాలి. Is my voice audible? Yes, it is VGS. I told you that gate VGS will be the input voltage to the FET. So input junction in FET is reverse biased. Input junctions in FET are reverse biased, whereas in BJT input junctions are forward biased. So VGS will be the input voltage. VGS will be the input voltage. So VGS. And if we take for N channel JFET, VGS, is it a positive or negative? రివర్స్ బయాస్ అంటే VGS నెగిటివ్ ఉండాలా పాజిటివ్ ఉండాలా?
నెగటివ్.
Yes, VGS negative. N channel gate P type ఉంటుంది. So gate must be reverse biased, means P type gate is connected to negative and N type channel is connected to the positive. So VGS must be negative, and whereas VDS must be a positive voltage, because when you give positive voltage at the drain with respect to source, then only the electrons will be attracted towards the drain and they will be moved to drain. So that is why VDS will be positive for N channel JFET and negative for VGS is negative. So we will write here 0, -1, -2, -3, -4, -5, like that. And here we will write 1, 2, 3, 4. 1 second. So as we discussed, the drain current, first we will draw the drain current, drain characteristics. So current increases linearly, and for higher values of VDS, so when wedge-shaped depletion regions are getting formed, the rate of flow of the charge carriers will decreases, so current will not increase linearly. So rate of flow will decrease, and finally it becomes 0. So a constant current. So constant current will be flowing through the channel. And that current we have called it as IDSS, drain source saturation current. So this is, let us say this is the curve for VGS equal to 0. So if you, this voltage we called it as VDS sat. This voltage we called it VDS sat. And if you further increase VDS, then the PN junctions will break down and suddenly a large current will result. So this is the characteristic of drain characteristics for VGS equal to 0. Now suppose we have applied VGS equal to -1. Suppose we applied VGS equal to -1. So when VGS equal to -1, ఇది 4 volts అనుకుందాం ఇక్కడ. Let us assume this VDS at 4 volts అనుకోండి. Assume that VDS at is 4 volts. If you observe this figure, when VGS equal to 0, let us assume that VDS 4 volts దగ్గర pinch off అయింది అనుకున్నాం. Let us assume that at VDS sat equal to 4 volts, ఈ wedge shaped depletions 4 volts దగ్గర టచ్ అయినప్పుడు we say that channel is pinched off and a constant drain current is flowing. Okay. Now, suppose ఇప్పుడు VGS minus 1 volt ఇచ్చాను నేను. I have given minus 1 volt. I have given minus 1 volt. Listen carefully. When VGS equal to 0, if there is no gate voltage, it required 4 volts. It required 4 volts to occur pinch off. That is where the wedge shaped depletion regions will merge. So 4 volts, at 4 volts, this situation, this condition has occurred. Now, suppose if I have given minus 1 volt, if I have given minus 1 volt, then what will be the drain VDS required to occur pinch off? I repeat the question. VGS, when VGS equal to 0, the pinch off has occurred at 4 volts. VDS 4 volts. Now, I have given initially minus 1 volt. I have given initially minus 1 volt on VGS. Now, how much voltage is required at VDS to get this situation? How much voltage is required at VDS to get this situation to occur? This situation to occur, what is the how much voltage we require? Is this voltage greater than 4 volts or less than 4 volts?
Less than 4 volts.
Greater than.
4 volts కంటే ఎక్కువ అవసరం అవుతుందా, తక్కువ అవసరం అవుతుందా ఈ సిచ్యువేషన్ రావాలంటే? ఆల్రెడీ మైనస్ 1 వోల్ట్ ఇచ్చాను. బాబు ఇక్కడ చూడండి. ఇది ఇనిషియల్ డిప్లీషన్ విడ్త్ అనుకోండి, when VGS equal to 0. So this is the width when VGS equal to 0. So this is the width for VGS equal to 0. సో అప్పుడు మనకి VDS 4 volts అయితే కానీ మీకు ఈ ఇంటర్నల్ రివర్స్ బయాస్ వల్ల because of the internal reverse bias voltage, pinch off has taken place. Now what I am saying, I am giving minus 1 volt. Now I am giving minus 1 volt. అంటే VDS 0, even at VDS equal to 0, because of this minus 1 volt, మనం VDS ఏం అప్లై చేయకముందే, because of this minus 1 volt reverse bias, already depletion regions will be penetrated into the channel due to minus 1 volt. Already depletion regions will be slightly penetrated into the channel because of this external minus 1 volts given on the gate. So ఇప్పుడు pinch off 4 volts కంటే ముందే అక్కర్ అవుతుందా, 4 volts తర్వాత అక్కర్ అవుతుందా? ఆల్రెడీ డిప్లీషన్ విడ్స్ ఆల్రెడీ పెనట్రేట్ అయి ఉన్నాయి minus 1 volt ఇవ్వడం వల్ల. ఇప్పుడు చెప్పండి, do you require
4 volts కన్నా ముందే అవుతుంది.
4 volts కన్నా ముందే అవుతుంది, కానీ అందరు చెప్పట్లేదు, అది నేను అంటున్నా.
Less than 4 volts.
ఎస్, లెస్ దాన్ 4 volts. ఇంతకు ముందు అయితే డిప్లీషన్ రీజన్స్ మనం ఎక్స్టర్నల్ రివర్స్ బయాస్ వోల్టేజ్ ఏమి ఇవ్వలేదు కాబట్టి 4 volts వరకు ఇస్తూ 4 volts వస్తే అప్పుడు ఈ వెడ్జ్ షేప్డ్ డిప్లీషన్ రీజన్స్ ఫామ్ అయ్యేది. ఇప్పుడు ఏంటి, మనం minus 1 volt నువ్వు VDS 0 నుంచి ఇంక్రీజ్ చేయకంటే ముందే VGS minus 1 volt ఇచ్చాం కాబట్టి రివర్స్ బయాస్ వోల్టేజ్ ఇస్తే ఏమవుతుంది, ఇది ఇనీషియల్గా కన్స్ట్రక్షన్లో ఏర్పడిన డిప్లీషన్ రీజన్. సో వెన్ యూ గివ్ minus 1 volt, డిప్లీషన్ రీజన్స్ విల్ బి ఫర్దర్ వైడెండ్ బికాస్ ఆఫ్ దట్ ఎక్స్టర్నల్ minus 1 volt. అంటే నీకు ముందే VDS 0 ఉన్నప్పుడే నీకు ఛానల్ విడ్త్ తగ్గింది ఇంతకు ముందు దాంతో పోలిస్తే. ఇది ఛానల్ విడ్త్. వెన్ VDS was 0, VDS ఇంకేం స్టార్ట్ చేయకంటే ముందే ఛానల్ విడ్త్ తగ్గిపోయింది డిప్లీషన్స్ రీజన్స్ వల్ల. అంటే యూ రిక్వైర్ లెస్సర్ వోల్టేజ్ టు అక్కర్ పించ్ ఆఫ్. యూ రిక్వైర్ లెస్సర్ వోల్టేజ్ టు అక్కర్ పించ్ ఆఫ్. సో VDS ఇది 4 volts దగ్గర అయ్యింది. ఓకే, ఇప్పుడు చూడండి, ఆల్రెడీ we have given -1 volt. So the pinch off will occur at 3 volts. Pinch off will occur at 3 volts. ఇప్పుడు నేను VGS 2 volts ఇచ్చాను అనుకోండి. I have given VGS 2 volts. So how much voltage is required to occur pinch off? VDS sat is how much?
2 volts.
2 volts. Suppose I have given VGS -3 volts. At what voltage pinch off will occur?
1 volt.
1 volt. So like that, the characteristic curves. Now if we draw the similar characteristic curve for VGS equal to -1. So we may observe that pinch off may occur సో పించ్ ఆఫ్ ఇక్కడ అవ్వచ్చు 3 volts దగ్గర, 3 volts దగ్గర అవుతుంది. అండ్ బ్రేక్ డౌన్ ఆల్సో విల్ అక్కర్ ఎర్లీ. సిమిలర్లీ ఇఫ్ యూ గివ్ VGS -2, so pinch off will occur pinch off may occur at 2 volts. So -3 అంటే 1 volt దగ్గర పించ్ ఆఫ్ అయిపోతుంది. సో బ్రేక్ డౌన్ ఆల్సో విల్ బి occurring early. So VGS -4, VGS is -4. So when VGS is -4, then drain the channel will be completely closed by the depletion regions and drain current will become 0. So now these are the drain characteristics. So if I give 4 volts, then depletion regions will, this is the width, depletion regions will be merging. So VGS -4 volts is there. This is the situation. So because of VGS, the entire channel is filled with depletion regions. So ఇక్కడ మీరు ఇంకా ఏమి ఇచ్చినా కూడా VDS whatever voltage you give 0 దగ్గరే pinch off అయిపోతుంది. For VDS 0 itself, the channel will be pinched off. So these are the characteristics, drain characteristics. From the drain characteristics itself, you can derive the transfer characteristics. ఇక్కడ చూడండి. So VGS 0. So when VGS equal to 0, what is the current? IDSS. When VGS equal to -1, this is the current. So this is the current. Current will decrease when you give VGS, when you keep on increasing this negative voltage on the gate, drain current becomes reduced. Because why? Because at smaller voltages of VDS, channel is becoming pinched off. అంటే తక్కువ డ్రైన్ దగ్గర తక్కువ పొటెన్షియల్ ఇస్తున్నావు అంటే less number of charge carriers will be attracted towards the drain end. So like that, when VGS is increased in the negative direction, pinch off will occur early and current decreases. So this is the current. So this is the current for VGS equal to -1. and this is the current. For VGS equal to -2. So this is the current for VGS equal to -3. And what is the current when VGS equal to -4? What is the current when VGS equal to -4?
0.
0. సార్ నేను క్లాస్లో ఉన్నాను, చెప్పండి. 2:15 to 4:15. లాస్ట్ అవర్ తీసుకుంటానులేండి. నో ప్రాబ్లం. సరే 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 సార్, నేను క్లాస్లో ఉన్నా, లాస్ట్ అవర్ తీసుకుంటానులేండి. ఓకే. So when VGS equal to -4, drain current will become 0. Now the transfer curve, we draw the transfer curve. So it is not going to be a straight line, it's going to be a parabolic. So this is the transfer curve. It can be approximated with a parabolic equation. With a parabolic equation. Now I will write here. Suppose, just we will summarize one more time. VGS equal to 0. When VGS equal to 0, the current is going to be the maximum current. Drain current is going to be maximum, and that current is called as IDSS. And ID equal to IDSS at VDS sat. At VDS sat. And let us say VDS sat is 4 volts. So VGS minus 4 volts apply చేసాం అనుకోండి. VGS equal to -4 volts. So with VGS equal to -4, మనం first case, if you remember, at one particular negative voltage of VDS, the channel is completely filled with depletion regions and current is 0. Current is 0. So whatever is the VDS, even if you apply VDS, even if VDS is increased from 0, drain current will remain at 0. So ఇది 0 ఉంటే గనక VDS దగ్గర 4 volts అవసరం అవుతుంది పించ్ ఆఫ్ అవ్వడానికి. లేదు VGS దగ్గరే -4 volts ఇస్తే ఇంకా VDS దగ్గర ఏమి ఇచ్చినా కూడా drain current 0 అయిపోతుంది. So in both cases we say that channel is pinched off. Now I will repeat that, the same thing. Channel is said to be pinched off at VDS sat, which is equal to 4 volts, or ఇంకో రకంగా కూడా అనొచ్చు. Channel is said to be pinched off when VGS equal to -4 volts. So just numericals I'm giving you for the easy understanding. So if you have any doubt, please let me know. We will discuss. Any doubts regarding this characteristics? You can raise. Very important for the long answer question. Yes. If it is clear, then we will continue. Or if you have any doubts, we will discuss regarding the working and the shape of the characteristic curves. Yes, students, are you there in the class?
Yes, ma'am.
Any doubt?
No, ma'am.
మిగిలిన వాళ్ళ సంగతి ఏంటి? 61 is not attending. I don't know why. Number 90. వింటున్నారమ్మా?
Yes, ma'am.
సో ఇక్కడ VGS నెగిటివ్ వోల్టేజ్ ఎక్కువ చేస్తున్న కొద్దీ ఛానల్ విడ్త్ తగ్గిపోతుంది. అంటే we require a lesser VDS for pinch off to occur. సో VDS తక్కువ వోల్టేజ్ దగ్గర పించ్ ఆఫ్ అయ్యింది అంటే VDS తక్కువ వోల్టేజ్ ఉంది అంటే తక్కువ ఛార్జ్ క్యారియర్స్ని అట్రాక్ట్ చేస్తుంది డ్రైన్ వైపు. అందుకే కరెంట్ కూడా క్యారెక్టరిస్టిక్ కర్వ్స్ ఆర్ గోయింగ్ టు షిఫ్ట్ డౌన్. Characteristic curves are going to shift down when you, for different values of VGS, if you observe VGS 0, so you will get the maximum current in which case? When the current will be maximum in JFET? When current is maximum in JFET?
VGS is 0.
Yes, so when there is no gate voltage, when there is no external reverse bias given to the gate, current is maximum. That is called IDSS. So if you keep on giving some negative voltage on the gate, then current decreases. So characteristic curves are going to shift down, And finally, when VGS equal to -4, I will draw that curve. When VGS equal to -4, how will you draw the characteristic curve? That is going to be the straight line. This is -4 volts. So when VGS equal to -4, current is 0. Even if you increase VDS from 0 to any positive value, so this is the situation which will be there in the JFET when VGS equal to అదే -4 volts ఇచ్చామంటే the depletion regions will be uniformly widened so that entire channel is filled with depletion regions. And see here this curve, current becomes 0. సో అదే ఇక్కడ డ్రా చేశాను. And the same point I have indicated here, VGS, at VGS -4, 0 అన్నట్టు. Yes, any doubt?
మ్యామ్
Ah,
VGS -4 కంటే ఇంక్రీజ్ చేస్తే ఇంకా ప్రాబ్లం అవుతుంది మ్యామ్, అంటే జీరోనే ఉంటుంది కదా.
ఇంకేం జీరోనే ఉంటుంది. It will be 0 only.
Breakdown కాదమ్మా.
బ్రేక్ డౌన్ ఏం కాదమ్మా, డిప్లీషన్ రీజియన్స్ ఆల్రెడీ కరెంట్ 0 అయిపోతుంది మొత్తం. ఇంకా కరెంట్ విల్ బికమ్ 0. బ్రేక్ డౌన్ ఎప్పుడు అవుతుంది? ఈ VDS ఇంక్రీజ్ చేస్తున్నప్పుడు ఇంటర్నల్ రివర్స్ when we are increasing this VDS, వెడ్జ్ షేప్డ్ డిప్లీషన్ రీజన్స్ అంటే ఛార్జ్ క్యారియర్స్ సోర్స్ నుంచి డ్రైన్కి వెళ్తేనే డ్రైన్ కరెంట్ ఫ్లో అవుతుంది. దట్ ఈస్ కాల్డ్ డ్రైన్. మీకు పిఎన్ జంక్షన్ VGS ఇంక్రీజ్ చేస్తున్నప్పుడు బ్రేక్ డౌన్ అయితే ఛార్జ్ క్యారియర్స్ విల్ బి మూవింగ్ ఫ్రమ్ గేట్ టు ఛానల్ నుంచి గేట్కి, గేట్ నుంచి ఛానల్కి, కానీ సోర్స్ నుంచి డ్రైన్కి వెళ్ళవు. బికాస్ VDS 0 అయిపోతుంది అక్కడ. సో అక్కడ VDS ఎంత పెంచినా కూడా బ్రేక్ డౌన్ అయినప్పుడు VGS -4 V కంటే ఎక్కువ పెంచినప్పుడు ఏమవుతుంది అంటే బ్రేక్ డౌన్ అయినా కూడా మీకు జంక్షన్ ఇలా ఉంది కదా, జంక్షన్ ఇది P, ఇది N, అంటే ద మైనారిటీ ఛార్జ్ క్యారియర్స్ ఇటు నుంచి ఇటు మూవ్ అవుతాయి, అంతేగాని సోర్స్ నుంచి డ్రైన్కి మూవ్ అవ్వవు. సోర్స్ టు డ్రైన్ దే వోంట్ మూవ్. సో దట్ ఈస్ వై ఇట్ రిమైన్స్ ఎట్ డ్రైన్ కరెంట్ విల్ రిమైన్ ఎట్ 0. సోర్స్ నుంచి డ్రైన్కి ఫ్లో అయ్యే కరెంట్నే డ్రైన్ కరెంట్ అంట. ఓకే, నౌ so whatever the transfer characteristics we have drawn, that transfer characteristics are represented by the parabolic equation. The transfer characteristic is not a linear curve, so it can be approximated with a parabolic equation. So this is the equation which represents the drain transfer characteristic curve. So this is the equation ID equal to IDSS into 1 minus VGS by VP whole square. So 1 minus VGS by VP whole square. So instead of -4 volts, now I will write it as pinch off voltage. The voltage where drain current is becoming 0, that is called the pinch off voltage. So I will write it as VP. So VP and VDS sat, both will be, one second. So here I will write VP, instead of -4, I will write VP. So pinch off voltage. So the transfer curve is represented as ID equal to IDSS into 1 minus VGS by VP whole square. So if you observe this equation, this is the equation which represents the transfer curve. This is the equation which represents the transfer curve. Now VGS, VP, both are negative quantities. For N channel JFET. So channel ekkada pinch off avutundi ante that will be given by this VP, and VGS is nothing but the voltage whatever is there on the gate, that is VGS, and where the voltage is channel is becoming pinched off, that is VP. So both will be negative for N channel JFET. Now suppose if you set VGS equal to 0, what will be the current when VGS equal to 0? Just substitute VGS equal to 0.
IDSS.
Yes, so same thing you are getting. Whatever we discussed in the working, the current is going to be the maximum current, that is called the drain source saturation current. So current is maximum only when VGS equal to 0. The same thing you can observe from this mathematical equation. So when you substitute VGS equal to 0, ID equal to IDSS. So here, if you observe, we have seen the drain current, which is a function of VDS and VGS. But out of these two, by giving reverse bias voltage on the gate, one second. So by giving reverse bias voltage at the gate, so wedge-shaped depletion regions and the field across the depletion region. Second. Out of VDS and VGS, the electric field across this depletion region is controlling the drain current. So the field across the depletion regions is controlling the drain current. So field effect transistor, it is called field effect transistor because the field across the depletion regions, field across the depletion regions is controlling the number of charge carriers which are moving from source to drain. So that is why it is called as field effect transistor. So ultimately the reverse bias of gate and channel junctions are responsible for the flow of drain current from source to drain. So even though VDS, VGS both are controlling the drain current, but majorly VGS is the controlling voltage in JFET. So that is why JFET, it is called as voltage controlled current device. So we will define few FET parameters quickly. So drain resistance. So drain voltage by drain current is called a drain resistance. So always any parameter, if you take any, whether it is a transistor parameter or a FET parameter, dynamic, by default the parameter will be represented as the dynamic parameter. It means change in the voltage to the change in the current. So resistance means change in voltage to the change in current, but which resistance we are talking about? Drain resistance. So therefore drain voltage, change in the drain voltage to the change in the drain current is the drain resistance. And coming to the transconductance. So another parameter, this is very, very important in JFET, transconductance. Generally, if we say conductance, it is I by V. Conductance ante I by V. So trans, again, trans ante, if I is the output current, I ante manaku okate current undi JFET lo. So far we discussed. So I is the output current అంటే డ్రైన్ కరెంట్. సో పైన డ్రైన్ కరెంట్ వచ్చింది అంటే కింద అవుట్పుట్ కరెంట్ వర్సెస్ ఇన్పుట్ వోల్టేజ్, అందుకే ట్రాన్స్ కండక్టెన్స్ అన్నాం మనం. సపోజ్ అవుట్పుట్ కరెంట్ బై అవుట్పుట్ వోల్టేజ్, సపోజ్ ఇఫ్ ఐ నాట్ బై వి నాట్, then we won't call it as trans conductance. It is simply conductance because output current versus అవుట్పుట్ వోల్టేజ్. కానీ ఇక్కడ మనం ఏమంటున్నాం? ట్రాన్స్ కండక్టెన్స్ అంటున్నాం. అంటే అవుట్పుట్ కరెంట్ వర్సెస్ ఇన్పుట్ వోల్టేజ్. సో ఐడి విజిఎస్. సో సిన్స్ ఇట్ ఈస్ అగైన్ డైనమిక్ పారామీటర్, డెల్టా ఐడి బై డెల్టా విజిఎస్. ట్రాన్స్ అంటే అవుట్పుట్ కరెంట్ బై ఇన్పుట్ వోల్టేజ్. అవుట్పుట్ కరెంట్ బై, I will write here I naught by VI. అందుకే దానికి ట్రాన్స్ అన్నాం, ట్రాన్స్ కండక్టెన్స్. ఓకే, నెక్స్ట్ I will tell you what is trans conductance. Amplification factor. So amplification factor is delta VDS by delta VGS. Delta VDS by delta VGS. Based on the definitions of these parameters, you can relate these three as the amplification factor mu is product of the other two. So we won't be using this equation much in the further topics, but this topic is very, very important for 2 marks. So this topic Define FET parameters RD, GM and mu and obtain the relation between them. So important for 2 marks. Okay, now coming to GM. So మనము బీజేటీలో ఎట్లయితే ఆల్ఫా బీటా ఇంపార్టెంట్, కరెంట్ గెయిన్స్ ఇంపార్టెంట్ అనుకుంటామో, ఇక్కడ ఎఫ్ఈటీలో జిఎం ఇస్ మోర్ ఇంపార్టెంట్. సో హియర్ whether GM should be higher or smaller. See, so GM should be as high as possible, because what the GM, higher value of GM represents, ikkada chudandi, it means for a small change in the VGS, large change in the drain current. Just one more minute I'll take, not more than that. Conductance. So I by V, I naught by V in transconductance కాబట్టి. సో అవుట్పుట్ కరెంట్ డ్రైన్లో ఏంటి, ఎఫ్ఈటీలో డ్రైన్ కరెంట్, ఇన్పుట్ వోల్టేజ్ VGS. ఓకే, సో హియర్ so generally what we expect, for small change in VGS there should be a large change in the drain current. For small change in VGS, ఎక్కువ వోల్టేజ్ అప్లై చేస్తేనే ఎక్కువ కరెంట్ రావాలి అని ఎక్స్పెక్ట్ చేయం కదా. తక్కువ వోల్టేజ్ అప్లై చేసినా కూడా ఎక్కువ డ్రైన్ కరెంట్ ఫ్లో అవ్వాలి అనుకుంటాం. సో దట్ ఈస్ ది ఎయిమ్, రైట్? సో అంటే ఫర్ స్మాల్ VGS దేర్ షుడ్ బి ఎ లార్జ్ చేంజ్ ఇన్ ID. అంటే GM ఎక్కువ ఉంటుందా తక్కువ ఉంటుందా? సో GM మస్ట్ బి హయ్యర్, must be as large as possible. So what is the significance of GM transconductance means? So GM definition you need to explain, and next you need to explain the physical significance of GM, that for the ideally there should be a large change in the drain current for a small applied gate voltage. For a small applied gate voltage we want to get a large drain currents. Therefore, GM must be as large as possible. So your digital electronics sir is not feeling well, it seems. Just now he called. He asked me to take the last hour. I will again continue 3:15. Okay. So we will end here. Few more mathematical derivations are there which are important for exam point of view. సో ఈ ప్రూఫ్స్ చాలాసార్లు అడిగారు, దిస్ అండ్ దిస్ దే వాస్ సో మెనీ టైమ్స్, అండ్ ఇది కూడా. సో దేర్ ఫోర్ వీ విల్ డిరైవ్ దెమ్, అండ్ నెక్స్ట్ వీ విల్ మూవ్ ఆన్ టు MOSFET. Okay then. So I hope